Hey guys, this is Mrs. Keith, and today we're doing notes over even, odd, and neither functions. So I'm going to try to do this Cami thing and see if it works because there's a lot of writing on here. So the first one we're going to talk about is an even function, and the meaning of an even function is that it is symmetric about the y-axis. Okay, so what happens to the x and y values in an even function? Well, let me see if I can move this down a little bit. So for every ordered pair that you might have x, y, a negative xy exists. So basically all that you're doing is just changing the sign of your x. So f of x, and f of negative x have the same y value. All right, and what I want you to look at over here on your graph of y equals x squared, right here is the y-axis, and on either side of that y-axis you should see a mirror image of that. All right, let's do another one. Oops. Okay, so how do you determine algebraically if a function is even? Basically, what you're going to do is plug in negative x. You're going to plug that in for x, and then simplify. If you end up with the same function, that you started with, then it's even. So what I mean is if f of x equals f of negative x, then it's an even function. Okay, with that being said, I'm going to practice one algebraically to see if it's even. So if you take this original function, f of x equals a negative 3x squared plus 4, we're going to replace the x with a negative x. So it's going to become negative 3 times a negative x, which is squared, plus 4. And that ends up, when you simplifying it, being negative 3x squared plus 4. Well, if you'll notice, this is the exact same thing that we started with right here. Therefore, it's even, since you ended up with the exact same thing. Okay, let's do odd functions. All right, if you have an odd function, then it's going to be symmetric about the origin. So what I want you to focus on, let me change this is your origin right here. If you notice, in diagonal quadrants, you have the exact same image. So what happens to the x and y values in an odd function? For every ordered pair, so every x, y, a negative x, negative y exists. So f of x and f of negative x have opposite y values. What that basically means is that when you plug in a negative x for your x, your y value should change signs as well. All right, let's go to the next part. How can you determine algebraically if a function is odd? So you're going to do the same thing that you did with the even function. You're going to plug in negative x for x, then simplify, just like before. If you end up with a function that is the exact opposite of the original function, And what I mean by that, all of the signs have changed. Then the function is odd. So another way to write that, I'm just going to scroll over here, is that f of negative x, so that's after you've changed the sign of x, it should equal a negative f of x. All right, let's do one and show it algebraically. So let me change this back to a pen. All right, so we've got our original function. I'm just going to write it. Whoops, I'm not using a pen, sorry. So our original function f of x equals 2x cubed minus 4x. I'm going to replace the x with a negative x, so that becomes 2 negative x, and I'm going to cube it, minus 4, replace that x with a negative x. And so that becomes, when you cube a negative x, it becomes negative, so a negative times 2 will be negative 2x cubed, and that negative 4 times negative x is a positive 4x. So if you'll compare this new function to the original, every single sign has changed. Therefore, this is odd. Okay, sorry, I had to scroll down so it erases what I just wrote with the pen. Hope that's okay. You can always go back if you need to. Now we're going to talk about neither. How can you determine algebraically if a function is neither odd nor even? So again, you're going to plug in negative x for x, and then simplify, just like we've been doing each time. If some of the terms change signs, but others stay the same, I guess I didn't need a comma there. Some English teacher will get mad at me, huh? But others stay the same, then the function is neither even nor odd. Okay, so if you look over here at this graph to the right, you can look at that y-axis, which is right here. You don't see a mirror image on either side of that y-axis. You also don't see a mirror image in diagonal quadrants. So that's a way to look at it graphically. So if you end up with a function that's not reflecting over the y-axis and it's not in diagonal quadrants, then it's going to be neither even nor odd. All right, we're going to now talk about how we know, just by looking at the exponents, whether it's even, odd, or neither. So first, let's see if I can put a bullet in here. So first, if all exponents are even, then the function is even. Hi, friend. Then the function is even. Oh. Sorry, Miss Jones came to say hi, and so I got distracted. All right, if all exponents are odd, then the function is odd. And if exponents are even and odd, then the function is neither. Oops, helps if you type neither, right? All right, I'm going to show you what I'm talking about by writing some example functions. So if I have something, I keep doing that, I'm sorry. All right, so if I have a function like f of x equals 3x squared plus 7x to the fourth plus, 9x to the sixth. We're focusing on the exponents. So we've got 2, 4, and 6. And since every exponent is even, this would be an even function. I'm going to give you another example of an even function. Let me erase that. if you have something like 2x to the fourth minus 7x squared plus 8. Now, again, you're focusing on the exponents. You've got an x to the fourth and you've got an x squared. Now, technically, this one over here has an x that's raised to the 0 power. And 0 is not really even or odd, but we're just going to, this would end up being an even function. So if you end up with just a constant, that's an even function. Okay, let's do another one. Okay, let's do something like 8x to the 7th plus 5x to the 3rd. Again, we're focusing on the exponents. Both of those are odd. That makes this an odd function. Okay, let's do another example. Let's say we have something like 9x to the 8th power plus 7, oh gosh, sorry. I don't know what happened there. Let me rewrite that. Sorry about that. That was crazy. All right, let's say 9x to the 7th power plus 8x to the 6th plus 5x to the 3rd, and I'll just stop there. Again, we're focusing on the exponents, and we've got both even and odd exponents. Therefore, this would be a neither function. All right, that's it for our notes. Thanks, guys.